And then now we will focus on calculating the acceleration and also finding the tension force re the objects that are connected by a string or a rope. The best way to explain this is by example. This example. It says a horizontal force of 100 newtons is applied to a 15 kilogram block which is connected to a 10 kilogram block by a light inextensible string. The force of friction on 15 kilogram block is 10 newtons, whilst the force of friction acting on the 10 kilogram block is 7 newtons. Determine the magnitude of the acceleration of the system as well as the tension in connecting the string. More than two blocks already connected by a string, and then more than force applied this 15 kilogram block to the right. These objects do move together and then they are to the right. This is because they connected by a string. So di tsamaya together and then they are to the right. What is important these objects di na le the same acceleration because di tsamaya together ka nako e tee. Ge question e ka re o calculate acceleration ya 10 kilogram or ya 15 kilogram is the same thing. Ge o ka find ya 10 kilogram block e tshwana le ge o findile ya 15 kilogram block. The same as ge o ka find this one e tshwana le ge o findile this one. This is because these objects di tsamaya together. Re di bona as a single unit. So now ge re tlo calculate the acceleration re tlo dira in this way. First ke tlo separate these objects. This one here 10 kilogram block in a tension. Ke cutile these objects into two pieces, and then the same here in a tension. So from there I'll draw a free body diagram here these objects separately. Ranali a weight force is always downwards, and then ranali a normal force is always perpendicular to the surface, because this is our surface, this must be a normal force. But this object in a frictional force, and then more tension is to the right. So ke free body diagram here this 10 kilogram block, and then now our level layer this 15 kilogram, and the same ranali a weight force, and then more force applied ke this force applied, and then ranali a normal force, and then ranali a tension ke this tension, and then again this 15 kilogram block in a friction, and then friction always in the opposite direction. Object here to the right, our friction over to the left. So a friction here, still you're not here in this direction. So now from here ke tlo dira F net here these two objects. Ke tlo re F net e lekana le MA. Remember re nyaka acceleration, and then ke tlo dira the same thing ka this 15 kg block. And then now re tlo substitute ka this F net. What we know for F net e re ka the vector sum of all forces acting parallel to the surface or parallel to the direction of motion. Object here in this direction. So the forces still already parallel to this direction. O ka kgona bona hore ke tension and friction, because this Fn and this W are parallel to this line. So re la hore re na le tension and friction as our F net. And then now ro lebelela a force yellow is going in this direction because object e rena ya to the right. So ka kgona bona hore tension ya to the right, so re la hore ya ba positive, and then because friction ya in the opposite direction re la hore ya ba negative. So from there re la hore ke tlo re T and then minus friction equal to MA, and then ke tlo dira the same thing on this 15 kilogram block. So ke tlo re FA and then got minus friction and minus tension, because for this one o ka lemoga gore the forces tse le parallel to this line ke FA and then ke friction and then ke tension. So these forces are parallel to the direction of motion, and then force applied here in the direction of motion, so re la hore ya ba positive, and then these two forces they are negative because they in the opposite direction. So re la hore from there ke tlo re force applied is positive, and then got a minus tension and then got a minus a friction equal to MA. So now let's substitute, but ga ke ne tension, so re la hore ke tlo re T and then got a minus friction ya 10 kilogram block ba re file yona, because ba rile the force of friction on 15 kg block is 10, and then ba re botsa gore ya 10 ke 7 newtons, so re la hore mo ke tlo re minus 7 and then equal to mass ke 10, and then remember gore nyaka acceleration. So now let's substitute for this one. Re na le force applied ya rena ke 100, and then tension ga re ne yona, but friction re na le yona ke 10, and then the mass ke 15, and then remember gore re nyaka acceleration. So from here re dira in this way, ke tlo dira tension subject of the formula here, and then ka dira tension subject of the formula. So re la hore ke tlo re T e lekana le 10A and then plus 7, ke tlo tšea this minus 7 and then ka isha to the other side, and then from there ke tlo re 100 minus 10 and then e re fa gore ke 90 and then minus T e lekana le 15A, and then from there ke tlo tšea this tension ka isha to the other side, and then ka tšea this 15 ka isha to this side because ke nyaka go dira T subject. Re la gore ke tlo re 90 minus 15A lekana le T, and then from there this one ke tlo bitša gore ke equation 1, and then this one ka bitša gore ke equation 2. So from there ke tlo equator these tensions. The reason ke equator is because the tension on the rope is the same. Remember this one and this one ke the same thing because re here re divide into 2, so re la hore ke the same tension, so re la hore from there ke tlo the equator because it's the same tension. So re la hore ke tlo re equation 1 e lekana le equation 2, and then from there ka re 10A plus 7 e lekana le 90 minus 15A. So from there ke tlo add like terms, ke tlo tšea 15 ka itlisha to this side, and then re la gore ke tlo ba le 10A plus 15A and then e lekana le 90 minus 7, so re la gore mo ke na le 25A and then e lekana le 83, and now because ke nyaka acceleration re la gore ke tlo divide both sides ka 25, so re la gore A e lekana le 3.32 meters per square seconds. So now re kry-ile acceleration. So now re nyaka go find the tension. Ge ke nyaka go find the tension, ke tlo tšea this acceleration ka substitute anywhere on equation 1 or equation 2, o tlo kry-a the same thing because these tensions di a lekana. So re la gore I can say T e lekana le 10A plus 7, and then ka substitute ka acceleration ya 3.32 and then plus 7. So from there it will fa 40.2 newtons. Remember, our tension is a force, and then this is our answer. When now this 3.32 and then we substitute on that equation, it will create the same answer. So this is our answer anyway, and that's it for this problem. What is important or draw a free body diagram, and then from there everything is straightforward. It's all about substitution. This one is two crates A and B with masses of 8 kilograms and 5 kilograms respectively are stationary on a rough horizontal surface. The crates are connected by a light inextensible string. When force F with a magnitude of 80 newtons is applied to the 8 kilogram block, both blocks move to the right. The magnitude of the frictional forces acting on the crates A and B are 7.68 newtons and 4.9 newtons respectively. Actually, more a similar situation, but the only difference is now this object is being pulled at an angle. These two objects initially are stationary, and then and then they in this direction. What is important generally a force yellow is at an angle. This force you create the components. You create a vertical component, and then you create a horizontal component. Or this object here to the right, it's because of this horizontal component. So this horizontal component is very important because when you calculate the Fnet, we consider this FH. But first, let's draw a free body diagram. A level layer 5 kg first. Ranally a weight which is downwards, and then roughly a normal force, and then mornally tension. Remember we divide into two, and then more normally friction because we're feeling normally friction, and then our level layer 8 kilograms. Normally a weight force which is always downwards, and then normally a normal force, and then more normally this tension, and then again we're feeling normally friction. So this friction over in this direction because object here to the right. So friction it's only even in the opposite direction. And then more normally force applied. This force applied is in this direction. This one. Remember draw a free body diagram. Include the components. This FV and this FH. But what I usually do regularly the components, the Fnet, calculate the acceleration. Always this horizontal component. Dira aside, but what I know draw a free body diagram, I don't have to include this component. You know what important calculate Fnet. So now let's find the Fnet here 5 kilograms. And then RDR the same thing, kaya 8 kilograms. So now for this Fnet, what we know the forces the act parallel to the direction of motion. So rogia this tension, and then radially this friction, and then tension here in this direction, here motion positive. So from there T minus friction. So this is T minus friction, and then elegantly MA. but now a re lebelele ya 8 kilograms. Re nyaka the forces tše already parallel to the direction of motion. This is our direction of motion. Re la gore the forces tše already parallel to the direction of motion yo ba F horizontal and then ya ba le friction and tension. Remember gore this object here to the right is because of this horizontal component, so that is why I include. So re la gore from there ke tlo re FH and then got minus tension and then minus friction and then equal to MA. But lemoga gore ga re ne FH, but re ka kgona go kry-a FH on this right angle triangle because ke mo e le gore go na le FH. Re tlo šomiša a trig ratio. Ke tlo re cos theta e lekana le adjacent, which is FH, and then over hypotenuse. Hypotenuse ke this force, and then ba re file gore this force ke 80 newtons. So re la gore ke tlo re divide by 8, and then from there ke tlo re FH e lekana le cos theta and then angle ya rena ke 30 degrees and then times 8. So more ke tlo re tension and then minus friction on the 5 kilograms ba re file gore ke 4.9, and then mass ke 5, and then re nyaka acceleration, and then let's substitute ka this one re ke ngwalele on this side. So ke na le FH re kreile gore ke cos 30 degrees and then times 80 newtons, and then ke tlo re minus tension and then minus friction. Friction ba re file gore ke 7.68 and then equal to MA. So mass ke 8 and then re nyaka acceleration, and then from there ke tlo add these two. So it tlo re fa gore ke 61.60 and then ka re minus 8A e lekana le T. Ke tlo tšea this 8A ka itliša on the left and then this T ka iša on the right hand side. So re la gore mo ke dirile T subject, and then re tlo dira the same thing here. Ke tlo re T e lekana le 5A and then plus 4.9. Then let's say this is equation 1, and then let's say this is equation 2. So from there ke tlo di equate. Ke tlo re equation 1 e lekana le equation 2. So from there re la gore ke na le 61.60 minus 8A and then e lekana le 5A plus 4.9. So now let's add the like terms. Ke tlo re 61.60 and then ka minus ka 4.9 ke tlo itliša on the left hand side. Ke tlo re 61.60 and then minus 4.9 e lekana le 5A plus 8A, and then 61.60 minus 4.9 e re fa 56.7, and then this one e re fa gore ke 13A. And then now because re nyaka acceleration re la gore divide both sides ka 13, therefore acceleration e re fa gore ke 4.36 per square seconds. So this is the acceleration. So from there re la gore re tlo tšea this acceleration re substitute anywhere on equation 1 or 2 gore kgone find out the tension. So re la gore ke tlo re 5 and then ka substitute ka 4.36 and then plus 4.9, so e re fa gore ke 26.7 newtons. Le ge o ka substitute here, remember gore e tlo fa the same answer. So mo re kry-ile our tension force. Let's see this one. A 15 kilogram block is connected to a 10 kilogram block by a light inextensible string running over a frictionless pulley. This is a pulley. A friction. The force of friction between the table and the 10 kg block is 7 newtons. So this block in a friction, and then it's 7 newtons. Determine the magnitude of the acceleration of the system as well as the tension in the connecting string. More a different situation, but I will apply the same concept. More a 15 kg block, and then it connected to this 10 kg block by a string. What is important assume this 15 kg block this 10 kg. So this 15 kg block it will downwards, and then downwards this 10 kg block it will in this direction because it will this string. So now I draw a free body diagram for this 10 kg block. The weight force, which is always downwards, and then a normal force, because this is our surface. This must be a normal force, and then this object here in this direction. So here in this direction a tension. Remember divider this tension on the previous example. And then a friction. So this object in a friction, and then that's about always in the opposite direction. So this is our free body diagram here, 10 kg FLH. And then now our level layer this 15 kg. This object downwards because tewa, but gravity which is always downwards. So more a weight force, and then more a tension which is upwards. So more a tension, and then this is our free body diagram FLH in this way. Remember a friction because a friction this object it's on the surface, it's in contact with the surface, but in this case a surface because this object is on the air. And then a normal force because a normal force it must be perpendicular to the surface, but a surface because this object is on the air. So now let's find the F net for 10 kg. F net ilekanale MA, and then we'll the same this one here 15 kg. So now our level here object here 10 kg here in this direction because here in this way. So now the forces still already parallel to the direction of motion. The forces still already parallel to this line. Tension and friction. And then because this object here in this direction, tension here positive because it's in the direction of motion. So T as positive, and then friction here negative. And then now let's see this one here 15 kilogram. Remember already for this 15 kilogram, the direction of motion this one because this object here tewa. So the force is still already parallel to this line. This tension and this weight. And then remember already this object here downwards, here in the direction here weight. So weight you positive and then tension you negative. So from there I will say W minus tension equal to MA. And then remember W ilikanale mg. so re la gore ke tlo re mg minus t e lekana le ma. And then now let's substitute here. Re na le tension and then minus friction ba re file gore ke 7 and then mass ke 10 and then acceleration. So more ro dira the same thing, ra substitute. The mass ke 15 and then g ke 9.8 minus t e lekana le 15 times a. So now let's make t subject of the formula. For this one ko ba le t e lekana le 10a plus 7, and then as for this one 15 times 9.8 e re fa gore ke 147, so ke na le 147 minus tension e lekana le 15a, and then from there ke tlo re 147 minus 15a e lekana le tension, ke jere this negative t ka isha to the other side, so ya ba positive. And then now re la gore this is equation 1 and then this is equation 2. So from there re ka di equate because these tensions they are tshwana, re la gore ke the same thing, ke this tension. So now let's equate. Equation 1 e lekana le equation 2, so re la gore ke na le 10a plus 7 e lekana le 147 minus 15a. So from there ke tlo ja this minus 15a ka itlisha on the left hand side, so ka ba le 10a plus 15a and then there fa 25a. Ke tlo ja this 7 ka isha to the other side and then ka ba le 147 minus 7 and then ka kry-a 140. And then now because re nyaka acceleration go divide both sides ka 25, so re la gore acceleration yo re fa gore ke 5.6 meters per square seconds. So this is our acceleration. And then now let's find the tension. So let's substitute on equation 1 or equation 2. So re nka substitute here go ba le, and then e re fa gore ke 63 newtons. So this is our tension force. So ka kgona bona gore it's not difficult, e no ba ile gore now re na le a different direction. So this is our answer anyway, and that's it for this problem.